All right. So a periodic relationship between two variables occurs when the output values demonstrate a repeating pattern over successive equal length intervals. So a periodic function repeats a pattern or a cycle over and over and over again. All right, the period of a periodic function is the length of the x values that it takes for the function to complete one cycle. All right, so if we didn't look at the words on example 1, can you tell what this one has 2 periods that have been graphed? Can you see what the cycle is? Or the pattern? Yeah, the pattern is this. So that's 1 period of that function. And then I know it tells you in the problem, but what is the length of the x values that it takes to complete that one cycle? 4. So this is going to have a period of 4. All right. And so we start off this point at -1, 1. And then if I added 4 to the -1, I'd get 3. And then the y value is still the same. And then if I add 4 to 3, I get 7. And the y value is still the same. And then that's going to keep repeating over and over and over again. Okay, so let's see what example 1 tells us that the period is 4. And we have a portion of it. So we're going to graph 2 more periods for this function. All right, so we're just going to draw that same pattern again 2 more times. And it would just continue going to the right with that pattern and continue going to the left with that pattern. All right, for example 2, we have a portion of a periodic function. We want to find the least possible value for the period of g. All right, so we could draw the cycle different ways. Did it one way last class. I think I'm going to do it a different way here. So I would say that that make up 1 period of this function g. So what is the distance on the x values for that 1 period? 5. Now, last class I drew it differently. I drew that this was the period. And that's fine. That's still going to be a distance of 5. So it could be different. All right, so on example 3, we're going to evaluate this periodic function for values that we can't see. So we have graph from -2 to 9, but we're going to do some that are outside of that range. So like I said on the last question, like here we had that the output was 1, and then if I added a period to the x, the output's still 1, and I keep adding that period. So what we're going to do is take numbers that are in this number line that you can see and add multiple periods or multiples of 5 to be able to get 14. I'm having a really hard time articulating that for some reason. So I want to take a number that you can see on this number line and add multiples of 5 to it, because 5 is the period, to be able to get 14. So can you think of numbers? A number I can add a multiple of 5 to and get 14. So it would be 4, and then the multiple of 5 you would add would be 10. So that 10 is 2 periods. All right. So what you can do at this point is just drop off that multiple of 5, because that is going to end up covering up my microphone. That's going to end up just giving you that same thing. That was g of 4. So you can drop off a multiple of 5. And then looking at your graph, what is g of 4? 7. And that's it. Okay. Now, if that's still confusing to you, it should be. Don't worry. We're gonna do a couple more with the graph, and then we're gonna do some more with the table. You're gonna be okay. Okay. So same thing. We want to take a number that we can see on that number line, add a multiple of 5 to it, and have it be 72. 2 plus 70. Yep. 70 is actually going to be 14 periods. It doesn't really matter how many periods it is, as long as that 70 is a multiple of your period. You can drop that 70 off, and it's just going to be whatever g of 2 is from the graph, and g of 2 is just 6. Now, so far, up until this point, we've been taking numbers and we've been adding multiples of 5. The graph repeats in the other direction as well, so we can take numbers and subtract multiples of 5 for it to work also. So if we get a number you can see on that number line, since it's negative, we're definitely going to subtract a multiple of 5 from it to be able to get negative 17. What do y'all think? Yeah, so it's going to be 3 minus 20. So that's subtracting 4 periods from 3. And that's going to be the same output value as g of 3 is. And it looks like g of 3 is also 7. All right. Number 4 is a table of values. It tells you that h is a periodic function, and it tells you the period is 5. I kind of wish it was something else, but I can't change it at this point, or it's just not going to work out. Obviously, the period is not always 5. It can be any number, any real number can be the length of the period. So 5 is easier to work with because it's easy to find a multiple of 5. But anyway, we're going to take an x value from this graph or from this table, and we're going to add or subtract multiples of 5 from it to be able to get negative 2. What do y'all think? 3 minus 5. All right, and then we can drop off the multiple of 5. So it's going to be the same as h of 3, which is just 0. All right, you guys try to do B on your own, please. So you take an x from the table, add a multiple of 5 to it to be able to get 6. Or technically we could subtract, but actually that won't work for these numbers. All right, and then drop off a multiple of 5. It's just going to be whatever h of 1 is, which is negative 2. Okay, and then for C is a composition of functions. It's okay. We're going to do the same thing. We're just going to have to do it multiple times. So 9 is not an x value that's in your table. So we need to take a number that is an x value in your table and add or subtract a multiple of 5 to it to be able to get 9. So that's going to be 4 plus 5. All right, then we'll drop off the 5. h of 4 is in the table. It's 3. And this is nice because 3 is also in the table, and that's just going to be 0. What do you guys think about D? So inside our parentheses, we have 5k minus 3. Any ideas? K is just any integer in the world. So if K is any integer in the world, is 5K going to be a multiple of 5? Yeah, so we can just drop it off. That just represents K periods. It's definitely a multiple of 5. So it's going to be h of negative 3. Now, negative 3 is not in the table. But we can take a number in the table and subtract or add a multiple of 5 to it to get negative 3. What do y'all think? Yeah, it'd be 7 minus 10. So that's just going to be h of 7, which is 2. Right? So a periodic function starts with a basic pattern, and then it translates that pattern repeatedly over the domain. So you can think of it as that a periodic function as a horizontal translation on top of itself. So like you just take that section and just add the period to it, and it just translates on top of itself over and over and over again. All right. So for example, 4. Where the period of h was 5, we could think of it as horizontally translating the graph 5 units to the left or right. It's going to give you the same graph. Okay, so on this last one, we're going to kind of use that idea. So the graph of f is periodic. You can see that it does repeat this pattern right here. 2 full periods of f are shown. We're going to find all input values of f that will yield an output of 1. So that's kind of a strange question, but we need to start off and find the period of f. What do you guys think? 4. That's going to be needed to answer this question. So we want to represent all input values that give an output value of 1. So looking at what we have graphed, what is one value we would put in for x and we would get an output of 1? I can see 2 of them, but we just need 1. 2. Now, it's not the only one. 6 also gives you an output of 1. If we continue to more, 10 would also give you an output of 1. And then if we continued it again, that's not good. It didn't do what I wanted to do. But 14 would. We could do it in the other direction and kind of see that other ones will as well. So let's just represent it. So the inputs were going to be x's. We would take that 2, or if you wanted to, you could take 6. They both work. And we're going to add 4k, where 4 is the period and k is an integer. So any positive or negative whole number, I could put that in. So if I wanted to put in 7, that would be 30. So if I put 30 in for f, I'm going to get 1 for the output. All right? Are you okay? No, it's kind of some weird concepts for us this morning that you're not super familiar with. Okay, so one good thing about this AP exam that's very different from the calculus AP exam is they pretty much have told us exactly what the 3 response questions are going to look like. And the third 3 response question is going to be very similar to what we have here. Now, there is another part that we haven't learned yet that we'll kind of add in here as we go. But this is pretty much what it's going to be. And this guy, Brian Passwater, has written like 15 of these for us to practice. So we're going to practice this a lot. So you're going to get super good at doing these problems. And they get more difficult. So the one we're doing together is probably the least difficult that you could possibly see out of all of them. One you're going to do for homework is a little more difficult. And then the ones we'll keep practicing is they're just going to get a little bit more difficult. But I want you to get the idea of it. All right, so for example 6, this is going to be very similar to the third free response question, and this is always going to be non-calculator. So the first 2 free response questions are calculator questions, and we've practiced ones like it. Like on each of our tests, I've made up a question similar to what that will be like. But then free response question 3 and 4 are non-calculator questions. All right, so the figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving minute hand. So I'm going to go ahead and just label that 8 inches. The center of the clock is 120 inches directly above the floor. So from the center of the clock to the floor, that is going to be 120 inches. All right, at time t equals 0 minutes, the minute hand is pointed directly at the 12. That's going to be super important in just a second. However, the clock is not working properly, and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up at the 12 is at time t equals 30 minutes. As the minute hand moves, the distance between the endpoint of the minute hand and the floor periodically decreases and increases. The periodic function h models the distance in inches between the input of the middle minute hand from the floor and the floor. I think there might be some extra words there, as a function of time in minutes. Okay, so the graph of h and its dashed midline for 2 full cycles is shown. So we have these F, G, J, K, and P points that are labeled on the graph. And there is no scale indicated and no axes are present. So even though we have a view, we have 3 horizontal lines. In this case, none of those are the x-axis. So don't think that is the case. And we don't have a vertical axis at all. So what we're going to do is determine the ordered pairs for each of these 5 points based on this clock situation and how far the end of the minute hand is from the floor. So what is the biggest distance that minute hand, the end of it, is from the floor? 128. All right, so that means that these maximum values are going to be at 128 at 12 o'clock. All right, what about the distance whenever the minute hand is pointing at the 3 or the 9? What is that distance? 120. And then what about the 6? 112. How did you get that? You're subtracting the distance of the minute hand from the middle of the clock, which is going to be 112. Very good. Okay, so that's half the battle. All right, now we're going to figure out where the y-axis is. So it starts off, like our F point starts off at a maximum. And the maximum is always going to be when this is pointing at the 12. So at time t equals 0, it is pointing at the 12. So that's great. I don't know if that's going to be the case when you guys do it on the AP exam, but when it is, that's awesome. So if that maximum happens at time t equals 0, then that is the y-axis. All right, and then I'm just going to go ahead and draw my x-axis. It's not going to be to scale, obviously. That's okay. But it's definitely below that 112 line. So this is when y is 112. This is when y is 0. All right, so what is the period of this function? Like how long is it going to take it to get from F to P, or from 12 o'clock back to 12 o'clock again? 30 minutes. This is a weird clock. Now, each one of these points, the minimums and the midpoints and the maximums, are equally spaced on our x-axis. And so what I like to do is find halfway points. And so this one, again, is set up a little bit simpler than it possibly might be on your exam. But what is the halfway point between 0 and 15 and 30? 15. All right, what about the halfway between 0 and 15? 7.5 or 7.5. What about 15 and 30? That's a little bit harder. So one thing you guys are going to have to do without a calculator is find halfway points. And so some of you are going to be really good at this, and you just did it in your head, and it's fine. Some of you it's going to be harder. Ones we're going to do tomorrow, these are all going to be decimal values. It's going to be hard for everyone to do it. So how do you do it mathematically? If you want to find halfway between 2 points, what do? You find their average, right? You add them together. So halfway between 15 and 30, you would add them together. I don't know why I wrote 4. And then divide by 2. So that's 45 divided by 2, which you still might not be able to do in your head. That's okay. You just go over and you just make a little division problem where 2 goes into 4 2 times. 2 goes into 5 2 times. You have to add a decimal point, bring down a 0, and that's where it is. So we're going to practice that a lot. It might have been a while before you've done things like that without a calculator, but you'll be good at it. Don't worry. Okay, so we're ready to answer this question. And the answer to the question is the ordered pairs for each one of these points. So we'll start with F. What is the ordered pair at F? 0, 128. All right, and then we'll just go through each of the points. So because we've labeled our axes, we've done the hard work. Now this is just given the answer. All right, so the next two questions are ones that we've actually done before today. And I'm pretty sure this is supposed to be I, not a J. It's okay. All right, so B says to refer to this graph of H from part A that we just talked about. The T coordinate of G is going to be T1, and then J is going to be T2. So on the interval from T1 to T2, so we're talking about from G to J. I'm not really sure why they worded it that way. It's not my favorite, but that's okay. We're talking about this little interval between G and J. Which one of those choices describes the graph during that interval? What do you guys think? Would you say it's positive or negative, the graph at that point? So when we're talking about positive and negative, positive is going to be above the x-axis. So H is positive. When it's above the x-axis, and H is negative when below. So this is definitely graphed above the x-axis. So H is going to be positive. Would you say H is increasing or decreasing in that little section? Decreasing, because H is falling from left to right, or there's a negative slope. It's a struggle bus today. Now, I know this year we've learned all kinds of different things about increasing, decreasing, when the rate of change is increasing and decreasing. So it's hard to keep it all straight. This is straight talking about H. So this is stuff that, like, before this year you learned about when H was positive and when H was increasing and decreasing. Now part 2 takes us to the new stuff that you guys have learned this year. How would you describe the rate of change of H? How the rate of change of H is changing in that interval. So when you're deciding how the rate of change is changing, you're looking at the concavity. Would you guys say in that little section the graph is concave up or concave down? Concave up. Concave up is going to look like a cup. And so would the rate of change be increasing or decreasing if the graph is concave up? Increasing. So we're going to say that the rate of change, I'm going to just quote the problem. You guys know I like to do that. Of H is, and then you guys said increasing. And I'm going to go back to quoting again. Over the interval T1, T2. It doesn't say to tell why, but I'm going to go ahead and tell why. You'll never get penalized for saying more than you need to, as long as what you're saying is true. Don't say that yet. So because the graph of H is concave up on those interval, or on that interval. Okay. So that's a good portion of free response question 3. And like I said, we have lots and lots of these to practice. The one that you guys are about to do, I'm just going to go ahead and tell you the y-axis is not right here. So it's not a situation where time equals 0 that you're at the maximum. So read what it is. You'll have to draw your y-axis somewhere off of what you see. So anyway, if you wanted to start with that one as the last one on your worksheet, it might be a good idea, and then I can come around and kind of help you. I have already recorded that, posted that